Continuing on, I'm going to do the first one for number 13, but because the answers are in the back of the book, I'm going to let you do the rest. And if you can't figure out any of the ones that after you see the answer, then you can email me and I'll show you how to do it. Now, in order to do these, you have to use the tables that are in the back of the book on solubility products, which is the Appendix J, beginning on page 1229. And so the first one here is KHC4H4O6. So KHC4 H4O6. And this breaks down, believe it or not, to K and HC4 H4O6. And I honestly do not know what that ion is called. And so the KSP is going to equal the concentration of K times the concentration of this other ion whose name defies pronunciation. Now what this means is if you look in the back, you'll see that the KSP for this is 3 times 10 to the minus 4. Now if you assume some amount here, really doesn't matter, that you get an amount X and amount X here starting at 0, okay? And so this would be whatever minus X. X is so small compared to whatever you start with here that you don't have to take that into account in your calculation. And so it's going to be equal to X squared. X for each of these concentrations. And so X, that is the concentration of each of these, is going to be the square root of 5 or 3 times 10 to the minus 4, 1.7 1.7 times 10 to the minus 2. Now the other way you can do this is you can actually assume an amount here, say 0.1, and do the long where you would have to for a concentration for this. And sometimes with these smaller numbers you need to do that, and that might be why the answer in the book, which is 2 times 10 to the minus 2, well actually that's probably just rounded up, because this number is only one significant figure, so this would be 2 times 10 to the minus 2. So I'm going to let you do the rest of these for problem 13. The next problem is problem number 24. Problem 24 states the following. Perform the following calculations. Calculate the concentrated silver concentration in a saturated solution of silver bromide. Well, you got silver bromide. It's going to silver plus bromide. Quite honestly, it's very similar to this. The KSP is going to equal silver ion plus bromide ion. And then you look up in the back in this table J, appendix J, excuse me, and silver bromide is 5 times 10 to the minus 13. 5 times 10 to the minus 13. So 5 times 10 to the minus 13 is going to equal, this is x, so x squared. So the concentration here is going to be the square root of 5 times 10 to the minus 13, which is 7 times 10 to the minus 7. So that's A. B, what will the silver be when enough potassium bromide has been added to make the bromide concentration 0.5 molar? Okay, use the same equation here, but instead of x and x, you now have x for silver and 0.05 for bromine. So 5 times 10 to the minus 13 is equal to x times 0.05. So the silver concentration here is going to be 1 times 10 to the minus 11. C, this is the common ion effect where you have the bromine is added. So now the concentration of this can only be this high if the concentration of bromine is that high. C states, what will the bromide concentration be if you add enough silver to make its concentration now 0.02? Same calculation, 5 times 10 to the minus 13 is now equal to 0.02 times x. So x is going to equal 2.5 times 10 to the minus 11. And the last one, D, nope, there is no D, sorry. Moving on to the next set, 28 and 30. So let's take a look at 28. The following concentrations are found in mixtures of ions in equilibrium with slightly soluble solids. From the concentrations given, calculate the KSP of each slightly soluble solid. So they just give you the concentrations, and all you have to do is calculate the KSP. So the first one's very easy because we've been working with this. It's going to be the silver times the bromine. So it's going to be 5.7 times 10 to the minus 7, and those are both the same, so we can just say squared. So that's 3.2 times 10 to the minus 13. For the B, it gives you the calcium and the carbonate concentrations. Now the interesting thing here is, given the fact that this one is also quite simple, it's calcium 2 plus times carbonate 2 minus, and they give you the calcium at 5.3 times 10 to the minus 3, and the carbonate at 9 times 10 to the minus 7. So it's going to be 4.8 times 10 to the minus 9. Lead fluoride is going to be lead. And now in this case, it's fluoride concentration squared. The concentration they give you for lead is 2.1 times 10 to the minus 3. And fluoride is 4.2 times 10 to the minus 3. That will be squared. So it's 3.7 times 10 to the minus 8. The next one is silver chromate, which is going to be the silver concentration squared times the chromate concentration. And so it's going to be 5.3 times 10 to the minus 3 squared times 3.2 times 10 to the minus 3. I think it was minus 5 here actually. Make sure I got that right. Yep. 9.0 times 10 to the minus 12. And the last one is going to be whatever that is times fluorine cubed. And so you get 2.3 times 10 to the minus 3 times 10 to the minus 3 times 7 times 10 to the minus 3 cubed. .9 times 10 to the minus 10.